Good afternoon. Thank you for being here. Just so you know you're in the right room, this is the session that's happening here. My name's Dan Rosnova. I'm a program management lead for Azure's messaging services. Today is my 1462nd day at Microsoft. And I'm here with SJ.
Yeah, good afternoon, everyone. I'm SJ, Engineering Manager of Event Hub Service. I'm super excited to be here.
Cool. So today's talk is about streaming big data in Azure with Kafka and Event Hubs. Just before we really kind of kick off, just a quick show of hands. Who in the room is familiar with these? Who's using Event Hubs today? Show of hands. Or who knows what it is? Okay.
And who is using Kafka? Great.
I'm not sure if you won that one, but we'll see. As we get started now, the place I really want to start with this is about just big data in general. And the talk will be more about streaming in particular. But just some thoughts about how big data really is if you look at what's happening in the world today, I'll start on I guess this would be right side of this. There are 4 million hours of content uploaded every day to YouTube. There are 3.8 billion internet users. That is more than half of humanity. 5.2 billion Google searches. 1.4 billion users on Facebook. I am not one of them. There is a Dan Rosnova. It's not me. And 60 billion gigabytes of data created globally every day. So think about how big that number is, 60 billion gigabytes. So that's pretty big. 269 billion emails. That was a number from 2017. I'm not sure how much that's really spam. I would guess most of it. And 22 billion text messages. And then a number that we're pretty happy with is 1.8 trillion requests a day going into Azure Event Hubs. So that is our daily run rate right now on a service that we've been running for just about 4 years. So the interesting thing about big data is there's all this data, there's all this information in the world that we're creating. But before you can actually do anything with it, you have to capture that data. You have to land it somewhere. And this isn't a new challenge. It's something we've done throughout the history of computing is you land data, you're doing ETL. Who here has done ETL at some point in their career? If I don't see every hand go up, I'd be extremely surprised. And really, you have to think about that. You're trying to refine the data. You're trying to make something useful out of it. Data by itself is really not information. It's not very useful. So we look at the way people do this, and historically, this has been through batch processing. So this is kind of the way all of us probably grew up in technology, is that you're getting data collected in batch files. Those batch files are being processed by some sort of ETL, whether it's kind of like AS400 type ETL, or whether it's something newer like kind of Hadoop type ETL. You're still doing ETL, and there's a lot of history here. I'd be really surprised if anyone in this room hasn't seen some sort of ETL-based batch processing in their careers. And it can have some benefits. It's like I said, there's a lot of history. It's everywhere, but it can be slow and it can be problematic. If you see things, my favorite is when you see stuff that runs once a day. It's like I shake my head at that. I spent a long time in real-time messaging before coming to Microsoft and in the trading industry, and every time I saw that, I was disappointed, and I fought it for a long time. And then I realized, though, that as slow as it can be and as cumbersome as it can be, it is everywhere. Batch processing is absolutely everywhere in the world. And I've come to terms with the fact that my last paycheck and probably my death certificate will be processed in a batch and probably on an AS400. But that's just life, and I'm okay with that. I'm getting there. But what's interesting is, well, a lot of that won't change. A lot of current batch processing stuff won't necessarily change. There's another way to do things that is growing faster than batch processing, and that is real-time processing. And this is something that this is what this talk will focus on. And real-time brings some interesting things with us, because for one, you can actually process individual data rather than sets of data. And while sets might be important, individual points of data or individual transactions are generally closer to what we're trying to model and what we're trying to deal with. Something like a purchase order, if I'm the person buying something, I really only care about my purchase order. I actually don't care about his. So, if I'm the developer developing it, we might think in a mindset now of the batch and the settlement and how you do this, but that's only because the tools we've had for 3 or 4 decades have taught us to think that way. But in reality, the business process tends to be more focused on individual transactions. You can get a lot faster end-to-end performance. So we'll look at kind of how batch stuff is done and how you can make that faster through real time. And then this is one of my favorites, actually, coming from the trading industry, is exception and settlement processes. These actually become pretty cumbersome with batch processing because you have to take all of the kickouts from a single batch, you have to make another batch out of them and do something with them. So the answer to your batch problem tends to be another batch, which is usually not a good answer. The real point of why this is important, why it's growing faster than sort of traditional like ETL and batch-based processing, is this idea, which I'm stealing from economic theory, the time value of data. It's kind of like the time value of money. It's like if you have money, you can invest it in something, you need to think about the interest rate. Sorry, financial background. To know what that money's really worth, what you can do with it. Data is kind of the same way. So if you can amass data for historical trends, that's pretty useful. That's how we build all of our models for things. But that data is actually extremely useful immediately. So if a fire alarm goes off, that's useful data right now. It's probably not so useful an hour from now. I mean, if my house was on fire, I'd want to know quickly. If no one knows about it, that's kind of a problem. What's interesting then is that data will lose value over time, if it's stale and nothing's happening with it, but it can regain value over time as you get more of it. So individual data points are valuable now, they lose their value, and collectively they become more valuable. And a lot of real-time processing right now is about trying to stitch these two things together. So the historic long-term data that you have to build your models, to build things like how we understand the world through machine intelligence today, and to be able to score and run that on real-time data sources so that you can tell if an anomaly really is an anomaly. So this is how you can do things like credit card fraud detection. Even though I buy a lot of strange things from different places all around the world, it won't fire off all the time just because my purchasing habits tend to be different than other people's. So this is kind of the why. Why do you care about real-time? Now let's talk a little bit about the how. This is a typical data pipeline. It has stages like this. This would be true if you're doing ETL and batch, or if you're doing real-time. Conceptually, they're not really that different. You have your data coming from somewhere, some sort of producers. These are usually the applications that are actually producing interesting data. Or in the IoT space, they're devices and machines. You're going to collect and stage that somewhere. Staging's the thing I'll talk about in a second. ETL people love staging. Then you need to land that data into somewhere, kind of a centralized store that you're actually going to do processing out of, which is your next step. And eventually you'll put it in some sort of nice place for long-term storage. And at the end, you get finally to presentation and action, which is really what our customers, what people, like collectively all of us, our customers, which tend to be business people, care about. They care about the ends of this. So where is the data coming from, and what are they trying to understand and gain insight and do with the data? The rest of this is just how the sausage is made inside. And no one outside of this room generally cares about it, unless it breaks. So when we look at how this works in traditional sort of ETL stuff today, what you see is that the staging stuff I'm dancing around is pretty core to ETL. You'll see it in files, so people use a lot of files. You'll see that there are benefits to files. Files are really easy to work with. If you're a developer working on your own or an integration person, you can take a file and write code against it or use tools against it and get repeatable output, and that's actually kind of nice. And they can actually support multiple read or rereading the file. So many people can read the same file, so it's non-destructive reading. That's kind of cool. And a file actually does contain a natural order most of the time. Whether it's a real order or not is a different question, depending on how the file was written. So these are actually some strengths with files. Another popular one is queues. People use queues in their integration pipelines a lot, in their ETL pipelines. Things like IBM MQ, that's pretty big, MSMQ, Service Bus, TIBCO, these sorts of tools. And queues are a bit different from files. They solve a few problems that files have. While files can have some nice things, the problem with files is that the file is a single resource. So it's hard to parallelize a single file, unless you're dealing with very big files where you can use Hadoop and MapReduce for that. So queues can scale out better than files because it's a competing consumer model. You have many consumers pulling from the same queue, which is cool. It's helpful. And they can be transactional consistent. So you can actually, some queues support transactional reads and writes so that you can read a message, put it somewhere else like a database, and then complete that message in an atomic transaction. That can be very useful. You don't want to lose data in this pipeline. That's usually, business people get very angry about that if they ever find out. And queues can't be replayed. So we're solving some problems, but this one's actually a pretty big problem, is once you read messages from a queue, you complete that message and it's gone. no one else can read that. And that's useful sometimes. It's not useful other times. And the kind of final way that this is, I've done way too much of this in my career, databases used for staging. This is a good one. Databases are cool, but they're very heavyweight, right? They've got all these awesome features. They're definitely transactionally consistent. You can totally do replay from them. You can mark versions in them and all these things. But just like the problem with the settlement batch, this is just more databases to manage. So you're trying to solve a problem, a database data transfer problem with databases. I mean, there's times and places for it, but it can be problematic. And the challenge for this is as you tie all these staging pieces together, you're really getting more and more latency all the way through. So if you stage in some drop area, 15 minutes later it lands in some staging table, 15 minutes later some other ETL runs, and before you know it, you've added up a lot of time. When we look at something like event hubs, and the same would hold true for Kafka actually, when we look at the same type of pipeline in Azure, we really can start really at the end, at the presentation and action, the things that our users care about. So dashboards, things like Cortana, things like mobile devices and search and query. And at the beginning, so the event producers. And these might be applications, legacy existing applications. They might be IoT devices. They could be a whole lot of different things. And then you've got all these pieces that I mentioned already in the middle. You've got some collection. Some of these will use staging to get into the cloud. Some of these will be directly connected to the internet and bypass that. And you're landing that data into an ingress buffer. Again, something like whether it's event hubs or Kafka, some sort of partition consumer buffer. Talk about what that means in a second. And then you're going to do some sort of stream processing on it. And what we've generally seen from 4 years of running event hubs is that there tend to be two types of stream processing that happen. One is a fast real-time stream processing. This is going to be your anomaly detection. This is going to be your fire alarms, things like that. This is actually what we originally designed event hubs for. But what's interesting is we actually saw that the slow data path is actually equally as popular. And I think in the 2 years in, we'd realized that about 80% of our customers, while they were all doing real-time, were also doing slow processing on the same data. The best example I've ever seen of that was Halo, the gaming franchise Halo. Halo has been very successful using analytics to improve their game every generation. So they gather a ton of telemetry about what people are doing within the game. They do a lot of analytics on it, and they actually make the game better based on the analytics that they've collected over time. It's not just that they're guessing, hey, what do people really want, and they just happen to be right every time. So they're pretty smart about that. And with Halo 5, they actually used one single telemetry pipeline, which was event hubs, to gather the real-time telemetry, which does things like player match or toasts when you, I guess it's when you kill people in Halo, I don't know. They tie that together to the same pipeline, actually feeding their big data, which is their historical analytics to improve the game. And again, after that, you get to the same things. You get to long-term storage, you get to presentation and action, and the tools that you use here kind of get bigger as you get towards this processing side. You'll see things like HDInsight there. You'll see things like Databricks. You'll see things like ADLS or ADLA. There are a lot of tools, Spark, Flink, that you'll see in that space. Real quick, I just want to talk about Partition Consumer a little bit. If everyone's familiar with Kafka or event hubs, this should not be a new concept. When you look at what a Partition Consumer architecture is, and both Kafka and event hubs are this type of animal, you have a construct that's really virtual called a topic in Kafka or an event hub in event hubs. And within that, you have partitions. Those partitions are physical stores of your data. That data is in a natural order there, and it's stable, so you can reread it as much as you want. And when you're sending to this logical construct that is the topic or the event hub, your producers are really just sending in. So if you take no further action in event hubs, we're going to round robin that data across all of the partitions. And that's going to give you really good availability, really good throughput. It's going to load balance all those partitions. Usually those partitions are running on separate machines. So that's not a detail you necessarily see since it's a cloud service. You would certainly see it in Kafka. Now to read from this partitioned stream, this partitioned log, you actually connect to it your consumers to each partition through a consumer group. And both event hubs and Kafka use the same terminology for that. It's a consumer group. You could think of a consumer group almost like a select star view into a table. So there's no filtering on it or anything, and if you want to read the whole stream and you have 4 partitions, you have to have 4 readers, one for each partition. So you're connecting this consumer group, all the consumers in it, they're reading. As they connect, they're specifying an offset. So where in the stream do they want to start reading? So where in that partition do they want to read forward from? And a cool feature for both of these, for both Event Hubs and Kafka, is that they're going to give you the ability to have multiple consumer groups. So many consumer groups, you can have different readers at different places in the stream, reading and going forward. This is a pretty powerful feature. This is an ability to add more readers as you go, grow your ecosystem. But just personally, from spending a long time in messaging, people kind of call this pub sub or publish subscribe. I personally would not call this publish subscribe, which is more of a, I don't know, that's more of a theoretical question, I guess. But when I look at publish subscribe, I'd look at something more like Event Grid or Tibco EMS or something like that, where you're doing routing on the publishing. In this, everyone is reading the whole stream, and that's an important concept to keep in mind. There's another analogy I like that some of you may have seen. I've talked about it a couple times in the past, and I think everyone, not everyone, but I think most of the people in this room should be old enough to recognize what this is. Anyone recognize this? Anyone had these? I had a lot of these when I was young. I probably still have some. So the tape is a cool analogy for this because a tape can play from anywhere on the tape, right? You just fast forward or rewind to the location of the tape you're interested in, and then you press play. And when you press record with tape recorder, it's recording both the left and right channels at the same time. So it's two recordings happening, and they're actually separate information. And so it's a good analogy to an audio cassette. And when you play that back, they're actually different. If you listen to like classic rock, you'll hear that the drums are on one side and the guitars are on the other side. That's actually, there's an audio engineering reason for that, that involved record skipping at some point, but it still demonstrates that there are actually two channels there. On a tape, there's technically 4 channels. And the speakers play back that information, and it's different information on each side. And an Event Hub is just like this, or a Kafka topic. And in those are called partitions. So those channels would be partitions. Same exact type of concept. Which analogy do people like more? The tape or the other one? Who likes the tape? No one likes the tape. Oh, that's sad. Okay. I shouldn't have asked that. Now I'm sad. So one other thing I want to talk about is moving beyond the queue. So what is a stream and how is it so different than a queue, and why do we make such a big deal out of this? I kind of danced around this a little bit, but it's the difference between a client-side cursor and a server-side cursor. A queue is a server-side cursor. You're saying to the queue, give me the next message you have, and it gives you that, and then you complete that message and it goes away. On a log, you're actually using a client-side cursor where you just connect at a point that you're interested in and you read forward from there. Both Kafka and Event Hubs give you the client-side cursor. And they're both replayable. I already mentioned that, but it's pretty important because you can add new consumers to read yesterday's data, and it's not destructive. Oh, hey, that's the one I was going to do next. And they scale out horizontally. This is probably the most important thing of the partition consumer model. If you use a competing consumer, like I'm trying to think what's the best analogy, maybe a registration line yesterday or Sunday. Like that is a competing consumer, right? You're standing in that line and there's only one person at the front of it to use, but they have lots of lines to make it go faster, which is a partition consumer. So it's a decent analogy, not perfect, but it's close. And importantly too, you can actually get strict ordering in that partition consumer model. And that's important for a variety of reasons. The first is actually that when you have this scale out, you think about how you're going to scale out. You want partitions. That's really the number of readers you want. So the number of machines that are going to be reading the stream is the number of partitions you want in general. And if you're doing that processing, you're thinking, okay, each machine has a partition, then you want all the data that machine needs to be local to that partition. Because if you have to start crossing processes to get more data, crossing machines, it's going to be slow all the time, right? So if you send to an Event Hub or a Kafka topic and you use a partition key like Dan, like my name, and you tag your messages with that key, then they'll always land in that partition that you tagged them for. So then Dan's data is always in partition 2. And SJ's data might be in partition 2 also, but they're in the same partition and they're in a fixed order. And that way the code running that's processing that doesn't need to branch across processes or across machines to get other data. So when you get to big scale, that actually becomes a really, really big challenge. So how do people stream today? These are probably the three of the most popular ways people stream. there's Kafka, there's Event Hubs, and there's actually AWS Kinesis streams. I couldn't put a logo on that because I don't know if we're allowed to use that. But Kinesis is an interesting platform too, if you look at it. And of these three, I'd actually say that Event Hubs and Kafka are more similar than Kinesis. They're really designed as streaming platforms, not as sort of micro-batch platforms. And looking a little bit deeper at platform now, when you look at how software is hosted, Kafka is cool as a tool set, and it's software you can run anywhere, but it's software you run. So if you're running Kafka on-premise today, who is running Kafka on-premise, not in the cloud today? Okay, cool, nice, we'll talk. You have a lot of tasks you're responsible for that. In the data center, you have to do things like procure hardware. You have to provide physical security, network power, virtualization layer. You have to do these things. And then you have responsibility for the stack above that. So the things you would normally think about, operating system, application, which would be Kafka, configuration for that, and users. As you move into IaaS, infrastructure as a service, we actually take a bunch of those things away from you. We make it a lot easier. You don't have to do the physical data center stuff anymore. And as you get to platform as a service, we get some more away from you. And as SaaS, you're really just focusing on the data itself, the actual application data, not the infrastructure. Real quick, I want to show a quick demo of streaming with Event Hubs. This is 8. So I have my computer running here. I'm logged into the Azure portal. And if I want to create new Event Hubs, I can just go create a new resource, do Event Hubs. Sooner or later, this will come back. I might just cheat and go to an existing Event Hub. Create one. And when I come in here, I can give this some name. The namespace name that I'm creating here is an FQDN, a fully qualified domain name. That's a DNS. You could think about it like a Kafka cluster. This is where your topics are going to live. I can say Dan's new Event Hub. And I can pick what SKU I want for this. I'll just go with the standard pricing. And I pick where this is and what Azure subscription it's in. And that's pretty much it. It's pretty easy from there. I will actually just go to an existing Event Hub I have right now and show you what this sort of looks like. I have these in here. And you get a nice dashboard view, all this stuff. And you can have, like I said, multiple Event Hubs in here. I have one in here right now. And if I click on it, I'll see a little bit of traffic through here. And I'm going to show you a little bit more traffic right now, actually, when these things render out. So sending and receiving from Event Hubs we've designed it to be very, very simple. And actually, what's interesting is that Kafka made some changes to be very simple, too, that we're happy about. When I look at sending to an Event Hub, you have this producer and you have this consumer that I had in the previous chart. The tough thing about Partition Consumer is you actually are responsible for reading from all those partitions. So there is actually a trade-off between what you're getting from speed and the ability to scale out and the responsibility you have for dealing with the stream then. Sending to Event Hub, super easy. I can see this here. I'm creating an Event Hub client. And then I'm just using that client created from a connection string to go send 100 messages in a loop. So this is a trivial, simple example. This is our .NET Standard client. So this is a .NET Core application that's going to do that. It's going to send 100 messages. And on the other side, to read from an Event Hub, we've actually built a high-level API that we originally built when we shipped Event Hubs like 4 years ago. It's called Event Processor Host. Event Processor Host is an agent that's going to be responsible for reading from all those partitions and handling leases to make sure only one VM, one machine, is reading from those partitions, and doing your checkpointing as you go through the stream. The cool thing about this is you only have to implement one. So I'm instantiating Event Processor Host. I'm telling it which class is my processor, and that's a class that implements this iEvent processor interface. It has 4 methods in it. I'll let you guess what these all do. Close async, open async, process errors, and process events. Any questions about those? I kind of hope not. And I'm just going to write out the messages when I get them here. So these are going to be pretty simple. 2 console windows are going to open. The first one in the background is going to just spew out 100 events. And Event Processor Host is spinning up on this other window. And it's going to go read those and go through and checkpoint. And you could see in my code here that it's getting some collection, and then it's checkpointing. So it's saving the offsets for where it was in that partition. as it goes through here. So this is just a simple example of how easy this is to do and how easy we've tried to make this. And the cool thing is that Kafka's actually gone and implemented a high-level API that's very similar to Event Processor Host. Their consumer API is simple, and it's a lot like this. And to look at what it's like to publish from Kafka, SJ is going to show some Kafka stuff right now.
Okay, so thanks, Dan. So luckily for Kafka, I don't have to write a code like Dan did because I already have all the kind of tools in the Kafka. So what I'm going to do is that I'm going to start the Zookeeper, and I'm going to start the Kafka, and I will just start both consumer and producers in this demo. So this one is just starting this Zookeeper. And then start Kafka. And then I'm going to just start, Kafka consumer application first. So this one is going to read the data from the Kafka topic, my topic 1. And since I haven't created, Kafka topic yet, so this is going to create topic on demand, and that's the default behavior. So now I'm going to just start the producer sending data to my topic 1. So then send it 100 messages. So what I have to do here now is I have to kind of type, 1 and then 200 times, but I'm not going to do that. So as you can see it here, kind of you see 1 and 2. So Kafka actually has a lot of the built-in tools and libraries that you can use for enabling your stream applications, which is pretty powerful tools. Okay, back to Dan.
Thanks. 5. So that was a quick demo of showing sending through Kafka. The sample that SJ used actually ships with the Kafka code base. So like he said, he didn't have to write any code there. And I did actually go into it and just pull out a sample of what the exact same thing that I did looks like for sending in Kafka. You can see from here, it's almost the exact same thing. You're just putting some properties in a connection property object, and then you're creating this producer. So it's a kind of the fifth and last line there, and there's a for loop that's just doing an asynchronous send to the Kafka topic. So that code looks almost exactly the same. Both of them do asynchronous sends. That's how fast stuff generally works. So you can kind of see that conceptually Kafka and event hubs are similar, not just from how they run, but how you interface with them through code. And now back to a little bit of running Kafka, because you can run it anywhere. SJ is actually running this from his laptop here. He has a Kafka cluster installed on his laptop. You could see it had localhost in the commands that he was using. And when you're running Kafka on premises, these are the steps you have to take to sort of set up your Kafka cluster, right? If you have a pool of hardware, you can just steal from that. But if you don't, you have a set of deployment steps and then a set of management steps. And those deployment steps, again, some of these things are easier than others. Physical network can be really hard, especially if you don't know what you're doing. My favorite is to go in and see people cut patch cables because they want the right length, not paying any attention to the phase on the cable and not understanding what that's going to do for the throughput of their network. So I've seen that one. It's fun. So when you get to something like Azure, how can we help you with this? Hey, you're running Kafka on your own. You're doing a good job. That's great. But you might want that to be a little bit easier. And so we can give you IaaS to make that a lot easier. You know, just by moving to IaaS, you're taking away a lot of that. So you're no longer responsible for all of those pieces that you had to do for procurement and physical aspects of the data center. And now you can just use IaaS and run that. In Azure, you could do that completely by yourself. You could use the marketplace, and you can spin up Kafka through the marketplace through there are 3 or 4 different versions available, or vendors' versions available, including Confluent Enterprise. So that's an option you have. You still do have to configure your virtual network and do all these other things. So it's not like you're getting a free lunch here, but you're removing a lot of your problems. And then the management side doesn't change very much other than procuring more hardware. You still have to do load balancing. You still have to do adding new nodes. You have to patch your OS. You have to babysit Zookeeper, rotate passwords, and set up things like security and SSL, which, if you know how to do, are not a challenge. Now I want to show you a little bit about HDInsight. 8. Yeah. And how HDInsight can solve a lot of these problems for you. So I'm going to come back to my dashboard here, my Azure dashboard. And looking at this, I can go create a new resource and create an HDInsight cluster. And I'm going to jump through this real quick and then just jump through to a cluster I already have. HDInsight is our Hortonworks data platform in Azure that's managing a lot of the IaaS for you. So this is a pretty cool tool for solving a lot of the problems that were still left on that list. I can give this a name like Dan's new Kafka. I don't know why I'm caring about spelling. Pick what subscription I want this in. I'm going to pick what kind of cluster I want. HDInsight has multiple cluster types. I can actually come in here and pick Kafka as my cluster type. I can see it's going to be on Linux, and I can see which version of Kafka I can pick. And I can select from here and go next. And now this is going to walk me through a little wizard, like adding in which users I want. So this is the cluster admin. I get an SSH user. I can create or reuse an existing resource group, new Kafka, and pick what region I want this in. And as I click next, this wizard is going to start validating my inputs and guiding me through the next steps of creating this cluster. One of the next things that's going to happen is I'm going to pick what sort of storage account I want. I'm going to be careful to use a new one because I don't know what else is in this subscription. And this storage account is really just for the metadata for the cluster. It's not, none of the Kafka data is in this storage account. It's using disks on the VMs to do that. So don't get confused about what this storage is actually doing. And if I click next through this, I can actually, this is a cool part, there's an app ecosystem for HDInsight, and I can pick which apps I actually want installed here. I'm not going to do any because that's not kind of the point of what I'm trying to show here. But here's where it gets pretty exciting, is I can say how many worker nodes do I want in my Kafka cluster. So the default's going to be 4. I can say how many disks do I want per worker node. So do I need a lot of storage or do I need a little storage? These are 1 terabyte disks, and that's per worker node. I can pick the size of those machines. So I can say, well, I really want, the default DV2s I'm pretty happy with. They've got 4 cores. They've got 14 gigs of RAM. Or I could kick this up to something larger, like an 8-core or whatever sort of machine I want. And I'll just stick with my default. And I can do the same for the head nodes and the zookeeper nodes. And then this little tool in the blade is going to show me how much per hour is this cluster going to cost me, which is nice to see, so you can kind of know what you're getting into. And it shows you your total core usage. So from here, if I just go next, we need a couple other questions. It's going to do a little bit of verification. I can actually run any scripts I want when the cluster is provisioned. So I can run bash scripts on the cluster as it's done. And I can actually pick virtual networks. This region doesn't have any in, but I could pick a VNet that I want this cluster to be in, which is a pretty cool aspect too. And if I hit next, all this is going to do now is come validate all of these inputs, let me edit any that I'm interested in changing, and even give me the ability to get the ARM template and parameters for this deployment so that I can actually just make this like an automated deployment. And I actually have a Kafka cluster already running, so I will just throw that away. And after you've provisioned this, you get some pretty cool stuff. So you come into the portal, the HDInsight portal, and I can see my HDInsight cluster here. I can see all the important metadata I want about it, like what its URL is. I can see how many nodes are in here, a little bit about the health of them. And I can actually go to the cluster dashboard and open up Embari and see what's going on in my cluster right now. So this is a pretty cool experience. I didn't have, literally, you click next, and the next thing you have is this. So there's no other work to do. And you can then go drill through and use the normal dashboards that you would expect to see for a Kafka cluster and see your health along this. So this has actually saved you a lot of work to get to this point. This is pretty useful, and it's a really useful tool, but it goes beyond just the provisioning step, and then I can actually come here and you can see I can either go through cluster size or I'll just go to scale. Scale my cluster. So I'm running my Kafka cluster now. Traffic's growing, which it tends to do with streaming pipelines once people start seeing the value and start wanting that data again and again. And you can come in here and actually scale your cluster and grow it to more nodes. Literally, I just say more worker nodes. I can say 6 or 10 or however many my subscription will let me have, and it'll add more. I hit save, and it's going to deploy them into the existing cluster for me. So that's actually, to me, that's one of my favorite pieces in this. You're not actually having to do the administration on the cluster to make all that happen, and it's actually a super valuable way to be running Kafka in Azure. And how this kind of all adds together is when you look at what you're still doing is you no longer, when you're using HDInsight, need to think about these physical components or operating system level components, and you're free to focus more on the application level, application in this sense being Kafka. So you are going to be load balancing your partitions. It is Kafka. You're doing that. You are going to decide when to grow or shrink. You are going to rotate your passwords. And you are going to take care of your security and things like that. So you still have a lot of control. You can log into the cluster and you can install your own binaries on it, so you can reuse that compute for other things. This can be really useful for a lot of people. Again, we've shifted your focus up to a more valuable part of the stack. There's not a lot of value if you're doing stream processing in configuring physical network. I guess unless you're doing high frequency trading, but that's a totally different story. So one of the things that people really like about Kafka is that it has a very rich ecosystem. So actually most of the people I know that use Kafka, and I almost say the same with Event Hubs, it's not that they care about the messaging broker itself. That's just the plumbing that's moving stuff around. They care about what it's connected into. So in Kafka, that's going to be things like Kafka Connect, Kafka Stream, Kafka Streams, sorry, there should be an S in there, Mirror Maker, other tools like Flink or Spark or NiFi. And these are kind of the real power of Kafka. Like, what are you using around that ecosystem that makes this so powerful? And Kafka's got a huge user community and a big tooling ecosystem around it that makes it pretty compelling. And one of the tools that I like a lot and that we see quite a bit of usage for is actually Mirror Maker. And Mirror Maker is a tool that lets you replicate your data between topics. So I have a Kafka cluster maybe in a warehouse or facility somewhere. It's collecting telemetry maybe off a manufacturing line or something. And I want that telemetry somewhere else. So I want to copy the data somewhere else, and I don't really want to write code to do it. And Mirror Maker is designed to do that. So it's really useful for like hub and spoke data collection. You can imagine if I have sites in multiple places where I'm producing solar panels or widgets or whatever, and I want to know about the data that's coming off that factory floor, I can actually collect that from all the factories and then analyze it back in one place. A way that we do this inside of Microsoft is if you think about the telemetry coming off of Windows or Office or tools like that, is those are deployed on your laptop and you're somewhere in the world or your machine or something. And we collect that telemetry as close to where you are in the world as possible, but it's one product team, even though the products are localized and things like that. It's one core product, and we want the usage data to be aggregated into a single place for that team to be able to improve the products and see what's happening in them. So that's kind of a hub and spoke data collection model. Mirror Maker makes that very easy to do without running any code. You can also do it for things like data backup and archive. That's pretty popular. Just say, hey, in case a meteor hits my data center, I want to have the data from these streams pushed to somewhere else. And then the last one is for data distribution. This one's actually pretty cool too, because we'll look at Mirror Maker closer in just a second, but you're actually reading from one cluster and writing to another cluster. So those clusters could be in different organizations. They don't need to be the same place. You can use different credentials for them. So you can actually push to a Kafka cluster that's not owned by you, that you're just given access to. So if you need to do like data distribution type stuff, this can be really useful. One thing to keep in mind with Mirror Maker is that it's not a fault tolerance mechanism. So this is not designed to give you like HA type stuff. What I mean by it's not a fault tolerance mechanism is those offsets in the topics are different between the two clusters. So the data is the same, but the offsets are different. And most of the time that doesn't make a difference until it does. So caveat with that. We do have some really good collateral about this because it's useful. It's super useful. So the HDInsight documentation pages have a pretty cool document writing up how to use Mirror Maker for sort of hybrid Kafka solutions where you might have on-premise Kafka and you want to do cloud-based processing. You don't necessarily want to get rid of your on-premise Kafka yet, and there are reasons you might not want to for latency or whatever else. But most likely when you're actually doing the processing, you might want to do that in the cloud because it's easier to scale and burst and get resources. So take a look at that documentation if you have a chance. So the power of Kafka is really in the ecosystem, and that's its core benefits. And we actually have a lot of advanced features in Event Hubs that are its core benefits. And they're kind of different in some ways and kind of similar in others. So when we look at them, some of the compelling Event Hubs features are the integration into the rest of the Azure stack. So things like Event Hubs working with Stream Analytics, things like Event Hubs working very well with Azure Functions. There's a really cool blog that the Functions team wrote a couple months ago, might have been late last year, about being able to process 100,000 messages a second in Functions coming off of Event Hubs. And that's a serverless implementation. That's pretty cool, and it scales quite well. Other things like Logic Apps or Azure Monitor, these are just sort of core pieces of Azure that this works well with. Event Hubs is a cloud-native service. It was designed to run in the cloud. It's not something we've lifted and shifted to the cloud. And as such, it's tied into a lot of the Azure core features, which I'll talk about all these in just a second: MSI, RBAC, VNet, and encryption at rest. Things like IP filtering. I'll talk about all the rest of these one by one, I guess. So the first one I want to talk about is Capture. Capture is a feature for Event Hubs that gets back to my genuine love for batch processing. I am being a little facetious there, I suppose. And that is that Capture automatically sends the data to a storage account that you provide to us. So instead of reading from a stream, which, believe it or not, reading from a stream can actually be challenging. It's easy when everything's going well. It can be harder when things aren't going well. And if you just want to back an archive of your data, that's what Capture is for. And it's made to better serve batching scenarios and archive scenarios. And that's exactly what we were going after with it. It minimizes your overhead for doing these because you don't have to write any code and you don't have to configure any other services to do this. So it's a very simple experience. And our idea here is that we want to enable batch and real time on the same stream. And this is a different approach than what Kinesis took, which is that we want you to take the fast and slow path after you've landed your stream, not before you send your stream. So you send your stream to one place, you make that decision later on. And it's largely because it can be easier to change your senders, your publishers, to be real time than your consumers. And that's because your consumers are the batch processes that you already have in place. And those tend to be a lot harder to rewrite. So with this, you can reuse your existing tools and processes for batch processing, even with streaming data. Very quick look at how Capture looks, how it works. You've got your old friend, the Event Hub here. You've got the partitions of data inside of it. You give us a storage account. It can be an Azure Blob account or an ADLS account, and you give us a time and size window. And when we hit that window, the first one of those things to be crossed, whether it's megabytes or minutes, we're going to write files for each of those partitions as they cross to that storage account. So now instead of reading from the stream, you have files that are holding that data. The data's still in the stream. You can still read the stream in real time, but this way you're getting windowed data. And you get to choose how you want it to kind of name the files and how you want it to actually write them in what sort of capacity of time and size. So this is the UI for Capture. It is pretty easy. You can see we've got sliders for both the time and the size. You're just picking them, and you're picking which storage provider you want. And you can't see it too well, but at the very bottom, you can see that there's a drop-down for sample naming formats. The pieces between the curly braces are macros. We need the macros for all of these because we don't want naming collisions. But you can put them in any order you want. You can put other text in between them. And this way you get the files named like in the example at the bottom of that. So Capture is pretty much the easiest way to get data into the cloud. You can do HTTP post to Event Hubs, and your data will get aggregated and end up in storage that you gave us. So it's something we're pretty pleased with. And if you've not tried it yet, please do. The next one is GeoDR. I'll go back for that. GeoDR is a feature that we shipped last year. And as I mentioned, 1,462 days into this job. I did have a real job before this. And part of my real job was to ensure business continuity for all of the software that the companies I worked at were running. And who has responsibility for that? Who needs to do DR planning or any business continuity stuff in your organization? Wow, you are so lucky that it's so few. So what we have in GeoDR is an ability to do disaster recovery between regions in Azure. We've created a concept called an alias. It looks like the DNS, the namespace that I created before, but it doesn't have a region, so it's global. And then you pick a primary region or a namespace that you want as your primary and a secondary. And what we're going to do here is we're going to direct all the traffic to the primary, so all your data is going to one place, and it's using that alias's fully qualified domain name, and we're copying that metadata It doesn't look too good up there. We're copying that metadata to the secondary. So if you create a topic in Kafka, would be the equivalent in Event Hub, we're going to create that Event Hub in the secondary. If you create a credential for that, a policy, a SaaS policy, we're going to copy that to the secondary as well. And if you create a consumer group, we're going to copy that to the secondary. The whole idea here is that your topology is the same between the two sites, between the two regions that you chose. And now if you trigger a failover, which is done through an ARM command, we will kick out the old primary, promote the secondary to primary, and your traffic gets redirected. So you can go back to sleep on Saturday night and worry about fixing that on Monday, which is, when I had a real job, was one of my biggest concerns, was how can I not have to be working all the time and keep our stuff running as much as possible. After you've done this process, the original primary, all the data is still there, all the stuff in it is still there. You can go read from that if you want to, especially if it was like an earthquake or something and the region was offline for a few hours and now it's back, or a day later or something. And when you're ready to repair again, you take the exact same setup you have, the same alias, and you add a new secondary to it, and you can repair back to whatever region you want. So what we're giving you here is user-controlled RTO, recovery time objective. So this RTO is 5 minutes. So you'll be able to do your failover and keep processing with a 5-minute downtime, even if US West falls into the ocean. Which, living now in an earthquake zone, I guess I should stop saying that. We have some other cool advanced features. Yeah, that won't be funny someday. One of the ones that we're shipping this summer is actually VNets, VNet support and event hubs. VNets are very popular for letting people have secured network access to individual Azure resources. So you can have all your virtual machines on a VNet and then give them access to something like an event hub, and then only those machines on that VNet can talk to that event hub and not public internet traffic. That's kind of cool. If you're not as into VNets, we're also shipping IP filtering at the same time with both accept and reject policies. So you can say, I only want these public IPs or these IPs to be able to talk to this event hub, or I explicitly don't want these ones. So maybe it's your biggest competitor or something and you don't want their IPs talking to your resources. Managed service identity. Anyone in the room familiar with that? I would guess that a lot of people have been hearing about that so far. MSI is actually one of the things I'm most excited about from my past experience about having for all of our toys, and Event Hubs is getting this as well. This is in preview right now. It lets you create an identity for resources in Azure, for instance, like VM scale sets or app service. And then that app service or that VMSS has an identity that you can grant it access to your event hubs, and you don't need to use connection strings anymore, because managing connection strings can be painful, especially in if you have really high requirements around that. And what that lets you do is use Azure Active Directory as your identity provider for the actual Azure resources. Another one in preview with that is RBAC, Role-Based Access Control. We have these both in preview. We're looking for feedback. This lets you provide access to users based on Active Directory user accounts, so that, again, you don't have to give people connection strings, and that you can limit what they're able to see in the portal and in the service itself. And then the last one that I'm really happy with is auto-inflate. This is a feature that was designed to solve actually our #1 support issue for a long time, was that when you create an event hub, we're trying to keep this low cost for you. So we give you the smallest package of resources because it's low cost. So I'll talk about throughput units in a minute. We give you 1. And it gives you like 1 megabyte per second. And most people, when they start with a streaming platform, they're starting small. It's departmental, or it's sort of R&D type stuff. And then the usage grows over time. But a megabyte per second, I mean, that's actually quite a bit of data. It's like 84 gigs a day. And what ends up happening is that as their usage gets higher and higher, people would start getting these server busy errors and being like, hey, why am I getting problems 3 months into using this event hub? What's going on? And what's happened is that they've run out of the capacity that they purchased. So we turned on a policy-based feature that will just grow your usage, your throughput units automatically. It's in that UI that I had up earlier for the actual event hub. You literally click a box and you say, how big do you want to grow? And so you have a control to be able to say, well, maybe I can do 10 megabytes per second, but if I'm doing more than that, someone's done something wrong and I don't want to be paying for that mistake that someone made. So you get policy-based control over this. This is pretty cool because you don't do anything and it just grows, but when you start, you can have the lowest level so that you can pay the least because you're not using much, and then automatically grow 1 megabyte at a time up to whatever your top threshold is. We look real quickly, yeah, you can see that okay. How we sell event hubs. We really, when you're looking at basic or standard, where most people start in standard, we have two things you need to think about. The first is ingress events, and the second is throughput units. Throughput units is the more kind of natural one to think of. It's megabytes per second. So it's a reservation for megabytes per second. Each throughput unit is giving you the ability to send 1 megabyte per second or 1,000 events per second. It costs 3 cents an hour. And then we charge you for the messages you send, but not the messages you read, and those are 2.8 cents per million messages. When you look at how our pricing is structured, we really have two models here because I don't think that one model will fit all for every scenario in the cloud, especially when you look at sort of sparse use case versus very large use case. So we have consumption-based pricing in pink, and we have resource-based pricing in blue. In the pink, you're paying for what you use. You're adding features like capture a la carte, and in the blue, you're just paying for the cluster itself, basically. So it's a single fixed cost. Scaling, I mentioned it's throughput units. These are the things you're reserving. How much? I got time. These are namespace-wide across all of the event hubs in your namespace, and unless you have auto-inflate on, we will throttle you when you run out of them. One thing I want people to keep in mind with event hubs is that we really did target this a little bit to my chagrin to be very inexpensive. And when we look at what that throughput unit costs you, so that's 3 cents an hour, that's 72 cents a day. You can send 1,000 messages a second with that. That's going to be 86 million messages if they're 1 kilobyte messages. And you're going to have to pay for those at 2.8 cents per million. That's $2.42. So 84 gigabytes of data with sub-second end-to-end latency and triple replication for $3.14 a day. And this model scales linearly. I don't have 86 million. I have 1 billion. You can do 1 billion events a day for $37. So a terabyte of sub-second triple replicated data. If you can find a cheaper, better, fully managed service anywhere, I'm not going to be offended if you use it. And it'll grow as you need it, which is kind of the other cool piece of this. So we've built a lot of cool stuff into our cloud experience to make this better, into event hubs. But a really cool question to ask yourself here is, what if we could combine these two things? What if we could take the benefits of Kafka and the benefits of event hubs and bring them together in a more natural way, where you're not having to choose as much between what you're doing, but you can start mixing pieces together. And for that, we'd like to introduce what we're going to talk about in our next section, our final section here, which is event hubs for Kafka ecosystems. This is something we turned on, I don't know if it's early today or late last night, so you can see it in the portal already if you want. This is a different idea about how we might want to do Kafka, a proposal for a different way to do Kafka than just as clusters. And it's a Kafka 1.0 compatible protocol on top of event hubs. So it's running event hubs, and it's got a protocol head for Kafka on top of it. It's in preview today. You can use it in your standard event hubs, so it'll work on very small scale. It'll also work on very large scale. And it's available in West US and East US right now. You can create this from the portal. I actually realized when I was showing you the portal earlier, there was a checkbox that had it, which that is new in the last few hours. So it wasn't there this morning when I practiced. And I think I kept my cool through it, so I don't know. And you can use your existing Kafka applications just by changing the connection string. And to show you what that really looks like, because we really want your feedback on what people think about this model, because this is a bit different than anyone else is kind of trying to offer Kafka right now. SJ is going to walk us through some final demos about using Kafka applications with event hubs.
Yeah, so I'm going to show you the portal website and then how you can enable, say, the Kafka for your event hub namespace here. So if you say log on to portal website, you can just create an event hub namespace. So if you click it, and you kind of click plus add, this one will introduce you just to say create an event hub namespace. And as you can see it, there is a kind of button here, enable Kafka. If you click this one, and you will be able to see, like say, these two different kind of West US and East US. So today we have 2 regions where this Kafka feature is available, and we are planning to add more and more regions as we build clusters for that. So let's switch back to the Kafka demos. So in my previous demo, I showed you how to use a Kafka client application and just talking to local Kafka. So now in this demo, what I'm going to do is I'm going to use the same application as it is. And then I'm going to configure my application just to talk to the event hub service instead of talking to my local Kafka. So I'm going to just shut down my the local Kafka because I don't need it. So here, as you can see it, there are a couple of things that you will need to modify for your Kafka application. It's not about your code, but it's just about configuration here. So if you just kind of look at the command lines here, you will have to first check the Bootstrap server. In my previous example, what I did was that, like you can see it here, Bootstrap server, I just specify localhost, which is my local Kafka cluster. But now in this case, I'm going to talk to the event hub service. Hence, this Bootstrap server will be my namespace full DNS name with port number 9093. And then I will also need to configure my application just to use secure transport. In my local cluster case, I don't have to set it. It's all within my, local machine. But now, since this one is going to talk to the service in Azure, I will need to set it. So I'm going to show you how to set these settings. So this is the setting file that I'm going to use in my client application. As you can see it, you have to kind of configure what is your secure protocol. So this is existing Kafka application, Kafka features. We don't add anything here. We just use that feature, just enable secure transport, secure communication between client and the service. So we support today this SASO SSL, and you can just say plain here, and then you will have to specify a couple of things here. So user ID and password. So user ID, its connection string, it's constant. In the future, we also plan to add, the SAS token support as well. In that case, this dollar connection string, it will be probably dollar SAS token like that. And then the password, you grab this connection string from the Azure portal website. For instance, if you go to this Azure portal here, so let's step back here. So this is my namespace, which I pre-created. And if you go to SAS access policy here, you click this policy, then you will be able to grab connection string from this button. So you kind of click this one, copy it, and paste it into this configuration file. So that's all that you need. So you just need to change the Bootstrap server, just pointing to the remote location, and then you just configure this security here. Now let's run the application here. So what I'm going to do is that I will just talk to my topic 1 here. I haven't created any topic in the cloud. So what we do is that if the client connect to service, then if the topic doesn't exist, we did create it. It's like how the Kafka does today. So I'm going to start my application here, my topic. So it's the same, my namespace, and then I just pass a setting. So since it's kind of fresh topic, there's nothing happening here yet. So I'm going to start my client application to send something. So let's type here, hello. Okay, here we go. So we just use the existing Kafka application with a couple of changes in connection string and this Bootstrap servers. And now I'm able to use the existing Kafka application just to talk to my event hub service. I think this is pretty awesome, isn't it?
Anyone like that? Yeah?
Yeah. Now this is kind of simple demo, but what if I have, the Kafka running on my on-prem or even cloud, and I want to, let's say, to migrate my data from this Kafka to the event hubs, right? So then introduce kind of Kafka Meter Makers and how useful it is. So I'm going to use that Kafka Meter Maker just to replicate my data from local Kafka cluster to the event hub service. So let's try that. So I will need to start this Kafka again. I'm going to use a local Kafka. So I will start the Zookeeper here. And then this is Kafka. So in this, the Meter Maker demos, so Meter Maker kind of requires 2 settings. One is for your consumer setting. In this case, Kafka is running on my machine, which is local Kafka cluster. So I'm going to just use existing Kafka, let's say, So existing Kafka consumer properties as it is. I don't modify anything here, but I can show it as well, just in case you're curious. This is kind of setting. So I'm just using the local host, which is my local Kafka. And then for the producer side, it is going to talk to the event hub service. Hence, I have to provide, let's say, full security information, including the bootstrap servers. Let's take a look at the configuration. So as you can see that this bootstrap server is going to be my namespace that I have in the event hub service. And then remaining the same as we saw in this client, the simple console demo. So let's just start this demo again. So I already have the local Kafka cluster running. And then I'm going to start, say, my consumer here. But this time I'm going to use this the different topic, which is my topic 2. So I'm going to start in. And this is a fresh topic, so there's nothing here. Also, I'm going to start this Kafka producer. But this time, I need a lot more data than just simply 1 to 3, like small number of set. So I'm going to just use the Kafka performance producer tool and just run it here. So I specify, let's say, 5 throughput per second. It's kind of sending to, say, local cluster, generating this 5 messages per second. Now I will start this mirror maker, just replicate my traffic. So I specify the topic name too. Oops, sorry, looks like I send it to, yeah, that's correct, okay. So my topic 2, I'm going to send it now. So mirror maker is starting and then kind of getting the data. So as you see that, like, say, data is being sent, and then the event hub consumer is reading the data from this event hub service. The Kafka client is reading the data from the event hub service using existing Kafka application with a couple of settings. Now, as this is happening, I'm kind of curious about what is the current lag. For instance, let's say, local Kafka, what is the current situation about the consumer groups? So what I'm going to do is that I will just say, kind of use the Kafka consumer group tool. Let's say just get the lag size. So I'm just running this thing to my local Kafka cluster. I have this mirror maker consumer group, so I can just check. So it shows that, okay, so the last and the offset is 284 and the lag size 10. So consumers are reading, let's say, up to 374. So I'm going to do the same thing against this, say, the remote service, which is event hub service here. So I'm going to just kind of get the list. So I have one consumer group here. So I will just, let's do this. Okay, here we go. So it's kind of reading it. Now, while this data is being read, I'm going to stop this client here. See that? Like, if I stop it, then all the data is cut off, so the consumers just stop running. And then I can just say, okay, let's say probably send like 100 here. And the consumer again can get the data back. So I can keep repeating this thing, like I can probably send it to 1,000. See that works? Okay, let's try 1,000. Here we go. 1, 2, 3. Yeah, let's stop it.
So this is using all of the existing Kafka tools.
Cool. How awesome is it?
Yeah.
Thanks, guys.
So we're pretty happy about this because this is using all the existing Kafka tools. He didn't download anything else or use any private builds of anything. This is normal Kafka stuff that you can use against your event hubs today. And our philosophy with this is that we're trying to make this experience be as easy for you to choose the right tool that you want. And that is because event hubs and Kafka are friends. Oh.
I like that.
I might have skipped that one a little bit. And then the other thing to keep in mind here is that Azure is going to give you every option you need here. So we're not really going to necessarily tell you right now how you should be using Kafka. If you're happy using it on-prem, that's great. And if you want to use it in hybrid, that's great. We have solutions for you there. And if you want to run it as a managed cluster or on IaaS, we can definitely help you out. And if you want to run a PaaS that's running Kafka, we can do that as well. And our whole point there is that all of this is backed by Azure's compliance and certifications and security and availability. So this is the kind of capability we're trying to bring to you to make it easy to do the data streaming that we talked about. So if you're interested in Kafka, try it out, either HDInsight or on IaaS or with the Kafka protocol head on Event Hubs, and let us know what you think. We are going to take questions for a little bit of time now. This is my Q&A slide. Please no questions about Seamus. That's who that is. That's a sensitive subject for me right now, so we'll skip that. But I thought I'd use this photo because it was Cinco de Mayo, and Cinco de Mayo is my 4-year work anniversary. So 1,462 days ago. So any questions?
Yeah, so are all the Event Hub features, all those work with the Kafka as well? So like the RBAC controls on topics?
I did not plant this person in the audience. But yes, so all of the things like capture, we'll actually do protocol translation, so you can write with Kafka and read with things like functions or stream analytics or logic apps. All of those work. On the RBAC piece, it will work for you as a user using RBAC, because RBAC is more user. For MSI, we haven't GA'd MSI yet, so we're not 100% sure how that will work, but it will work eventually. The main thing is how to shoehorn it into SASL, so because SASL is the authentication protocol used by Kafka.
Yeah,
Great question.
Yeah.
Go ahead.
Yeah, the idea is just to make sure people who kind of get the benefit of Kafka plus the Event Hub at the same time. Yeah, so.
Yeah, that's awesome. That's our big issue with Kafka right now. So.
Thank you.
When's
And
it coming to
actually,
Central?
I was supposed to say that on my last slide, and I forgot to, so thank you.
When will it be available in Central US?
Central, yes.
Central, yes. All right, we got you.
Hey, what sort of performance trade-offs do you get if you are running the Kafka client against Event Hubs versus against your own managed Kafka? What are the are you making any trade-offs from a performance standpoint, or can you assume Event
Well,
Hubs?
you're always making trade-offs.
Yeah,
I would say
what are
that the biggest trade-off you're making is that we don't actually at this time support volatile messaging. So we will always triple replicate your data, and replication is optional in Kafka, so that we don't do volatile today. So that's the main trade-off you're making. Yeah. But it means we won't lose your data either.
Question for you on I was doing a little bit of research online, and the maximum partitions is 32, is that correct?
So I didn't really talk too much about dedicated event hubs. In our standard model, we do have a max of 32. If you need more, you file a support ticket, and we'll
Right.
increase your throughput units and your partitions. But if you really want to go crazy and have a lot, we actually have that dedicated model. At certain scale, usually it's around 50 throughput units, 50 megabytes per second. It's actually more cost effective usually to go to a dedicated cluster because you don't have to pay for all of those throughput units in hours. You're just paying for compute. You don't pay for messages. So believe it or not, 2.8 cents per million sounds pretty cheap, but at 100,000 a second, it adds up pretty quick.
Right.
Whereas when you're on dedicated, you don't pay for that. So if you want more than 100 partitions, I would use dedicated.
Okay, and then, so the theoretical scaling of the system, could this, because like LinkedIn is the major Kafka, I mean, that's where it all started. Could this, in theory, be scaled out to that level of throughput?
Do you mean for event hubs or for the Kafka protocol head?
For the event
For the
hub.
whole thing. Yeah, so when we launched event hubs, the Halo thing I mentioned, in 2014, Halo was doing 1.2 million messages per second through a single event hub.
Okay.
So
That-
we are past that now, yes. We have actually improved since then.
Okay, good, thanks.
And what about the Confluent schema registry? Can you use that through this protocol as well, or does Event Hubs have its own kind of schema management? What's the best way to address that kind of issue for
That's
producers?
a good question, because the Confluent ecosystem is a lot of sort of enterprise tools around Kafka, and you're buying those tools from Confluent. So I guess if you had the license to those tools, I actually don't know if that would work. You could use perhaps Event Hubs with those, but those tools like come from Confluent. They're not part of the messaging broker.
I believe the schema registry, I thought they open source as well.
Yeah. So I guess you could, but those, I don't believe that is actually in the broker itself. I think that's sugar around it. I'm not 100% sure.
Yeah, I'm also not 100% sure, but as long as it remains within client, you will be able to leverage all the features that you have today.
Okay. Does Event Hubs have any kind of schema management from a producer standpoint when you need to add field to your stream?
Yeah. So one thing that we do in Event Hubs that is a little bit different than Kafka is our messages have a header all the time because our native protocol is AMQP. So there's a map for the header, and you can put whatever you want in that header as long as they're primitive values, and that is where people usually register their own schema stuff. Yeah, that's super common. In Kafka, you don't have that header. You have the message itself, and that's what the schema registry is probably stamping schema into the messages from producer. Good question.
So the problem with the mirror maker is that it doesn't mirror the offsets, so the offsets will get misaligned. Does GeoDR solve that problem where consumers do a failover? Could you automatically consume from where you left off?
Yeah, so today, GeoDR, what's GA right now, is not the data in the topics. It's just the topics themselves. So then the offsets would be different. What should we talk about? Yeah, okay, so we are building in data replication as well, and that will actually have the same offsets. But that's something we haven't done yet. It's just something we're working on. And then you would have the same offsets for the same topics in 2 different clusters.
Mm-hmm. And also, second question. So Kafka can have retention more than 7 days, but I know Event Hub is only up to 7 days, right? So is there any plan on?
This is my favorite question. So how do you have retention for more than 7 days? My pushback on this is that I'm not sure if it's really a good idea. Because I mentioned the 1 megabyte per second. That's 84 gigs a day. In 2 weeks, you've got 1.2 terabytes of data. And now if you want to catch up, you've got to read 1.2 terabytes of data. And that's a lot to process. It's going to be hard to catch up on a small stream. So when you get to a big stream, I mean, if you were doing 50 or 100 megabytes a second and you got 2 weeks of that, I'm not sure if you're ever going to catch up, especially if you're producing more all the time. But that is actually why we built that capture feature, is if you want to be able to say, I want to go back 6 months and look at data, then you can. And capture works really well with the policy, lifetime policy stuff in Azure Blob Storage, because you can make your storage account automatically age out the capture files global in the storage account. So everything in this container will go away when it's 6 months old, and you can mark those things as immutable so that you can't mess with them until they go away. So I would probably look more at capture, because people bring this up for like the event sourcing pattern, and event sourcing is really cool in my experience until you scale.
Yeah, we're trying to do that. Sorry, one more question is,
yes.
So Kafka has unlimited message size, and Event Hub is up to 254 kilobytes.
Yes. So in Kafka, we've actually changed that. So our Kafka head does all of the defaults of the Kafka client. So we do 1 megabyte. And we don't let you go unlimited. We are looking at what size people want, but even at a megabyte, there's a point where you're looking at a file rather than a message, and we're not sure how people should really be doing that. A stream is kind of an expensive place to put images, for instance, like a claim check pointing to that image, and that claim check being in something cheaper like blob storage might be a better pattern. Great question, thank you.
Hi, Dan. Nice to see you again.
You as well, thank you.
Yeah. So quick question. We understand this Kafka event hubs are really for the streaming data, real time. But our use case is more like we have on-premise relational database, and with all the transactions, you have the data coming. We want to kind of do the near real time to move the data from on-premise to the cloud.
Yeah.
And we were thinking use Kafka or event hubs. Would that be a bad idea, or?
No, actually, a few CDC change data capture tools already do that today. One of them I just happen to know off the top of my head is Attunity. Uses either Kafka or Event Hubs as the transport mechanism to do CDC between your on-prem, like SQL or Oracle, and another instance somewhere else. So that's actually fairly common.
Actually, I'm glad you proposed the CDC, because we were thinking about the CDC. And we have lots of CDC connectors for the Oracle, but there was no open source for SQL Server, unfortunately. So we had to go with some commercial solution, like Stream, for example. I saw like on one of your slides, I see like Stream, quickly glancing through. Seems like you guys have Stream on the, the Azure right now, but those are kind of very expensive. So, is the Microsoft going to provide any CDC connector?
Ooh, that's my world is the messaging space. Once we get past that, I'm outside of my comfort zone, so I can't really speak to that. But you should stop by the data booths where we're hanging out, and we can find someone there to answer that.
And also we have another kind of question is we also have some other data sources, like a file-based, right? Like a very legacy applications. There's no CDC type of thing for those. What's your recommendation to, or is it possible to do any real time for those?
For file-based, I'd be looking more usually at something like Azure Data Factory.
Okay.
I talked all of this about streaming, but sort of the twin to streaming is native batch, which you don't want everything going through a stream, and Data Factory is made to kind of be like that SSIS in the cloud.
We actually have lots of experience with Data Factory. We actually team up with Microsoft for a long time. And the Data Factory, the high frequency is like 15 minutes. So sometimes we think 15 minutes is not good enough.
Yeah.
Because too slow, right?
The good news is the Data Factory team's working with one of our other teams, the Event Grid team.
Okay.
So there will be fun stuff coming there.
Oh, okay. Thank you.
Hi, we actually have a very similar use case. We just implemented CDC with Attunity into our on-prem sources, and we were looking to POC the HDInsight version of Kafka in late 2018. What would be your guys' recommendation, and kind of what implications does this product have for the HDInsight offering?
Yeah, so that's a good question, and in my mind, if you're comfortable running Kafka and you just don't want to do all of the grunt work to do it, HDInsight's a great tool for that. It's going to give you a cluster that you can install your own binaries on, that you can do all that stuff, but you are going to be responsible for that cluster. So if you don't have the capability of doing that, I'd be a little bit wary of it, but if you have that capability, absolutely, especially because HDInsight's going to make it way easier than running yourself either on-prem or on IS. So it's a very good solution for that. When you look at something like Event Hubs, since you can't install your own binaries, you can't use that cluster for other things. You can't go make specific low-level like jar changes or code changes on Kafka itself. So if you need those, then Event Hubs for Kafka ecosystems isn't really the right sort of approach for you. But if you want something smaller, maybe you don't need a whole cluster or something to start with, it's a good fit. And since they're protocol compatible, you can actually switch at some point from like Event Hubs to HDInsight. And that's not going to be, yeah.
Thank you.
My question is kind of similar to what they had. We have on-prem SQL and non-SQL databases, if you will, and we are using HDInsight to move it to HBase. One of the challenges that we have is when we want to seed the HBase database from on-prem, it's about 2 or 3 terabytes of data. Is there a bulk route that we could take or in the Kafka?
Yeah, so now you're crossing the line of where it's better sometimes. As much as I'm belittling batch, sometimes it's better to do ETL than to do streaming, and that's the time when it becomes better. So you don't necessarily want to take a year or a month of data and pump it through your real-time pipeline.
So to seed the data, you recommend using a batch ETL, then for real-time or near real-time, use Kafka to get the data?
Yeah, and actually that's a mistake I've made in my career, was not doing that, saying, oh, I'll just build this real-time thing and we'll just do one big push at the beginning.
Yeah,
and then everything starts smoking and falling over. So don't do that.
Yeah. And the second question is there any concept of priority queues or priority topics?
No, neither Kafka nor Event Hubs do priority at this time. Yeah, that's a feature that you'd usually find in something like IBM MQ or MSMQ, or maybe at some extent to Service Bus if you used routing to do priority. So no, neither of these brokers do that.
And there's no plan on adding any of those?
Sorry?
Is there any plan on adding such similar?
I don't believe the Kafka team is planning to add priority at this time, and I know we're not.
Okay. All right. Thank you.
Thank you. Real quick, just so everyone remembers, please fill out your evaluations. These are important, especially if you liked our session. If you didn't like it, it's okay not to.
One of our challenges in HDInsight Kafka is just topic security, not being able to lock down using RBAC based on different users. I thought there was a premium cluster type or premium security cluster type available. Is there any updates on that? Is that still a priority on the roadmap?
I actually don't know the answer to that one off the top of my head. I know it's something that's being worked on, but I also know that part of that's dependent on upstream work that's happening in Kafka itself for a better authentication model. Yeah. I'm sorry, if you come by and see us at the booth, we can grab one of the HDI PMs to tell you more.
Sure.
All right, and with that, we are over by 5 minutes. Oops, sorry.
Thanks, guys.